All right, problem number 10. This is clearly a conservation of momentum problem. And how do I know this? They mention the word collision for goodness sake. So whenever you see the word collision, don't even hesitate. I'm going to just jump right in. We're going to need this formula. And I like how they write it here. Somebody use their letters. mx vx plus my vy. This is the before and after. You know what? So they kind of do it this way. I'll do it like this. Px plus py capital equals lowercase px plus lowercase py. That's how we want to write this. So we want to know what is the correct conservation of momentum equation. Now, here's one thing I've realized. Let's be clear. It seems to me we're really being clear where we're talking about the magnitude of the momentum. So I'm really tempted to pick this one as the answer. But it's not going to work because clearly we want to take direction into account. So to this end, I'm going to actually change my answer just a little bit. And I'm going to actually subtract off the py here. And so when I actually work with this, that's going to actually give me answer B as the correct one. All right, this one here, f, d, theta, whenever I see a problem like this, I don't even want to do any thinking. I see f, I see d, I see theta right away. I'm going to write down the work formula, okay, from my notes. So now let's read. Point of action, constant force, distance d, angle. Oh, which is the correct expression for the work done? There you go. Choice C. All right, so let's talk about energy. Which one was the true statement of energy? Energy is never destroyed. Power is energy or work over time. But maybe more energy isn't available. Maybe I have something delivering power, but it shuts down so quickly I don't get more energy. These do not measure the same quantity. Okay, power is energy over time. Energy actually is a measure of the ability to do work. All right, we have a mass moving in a horizontal circle. Velocity v. There's p. There's q. So one thing I want to draw right away, I want to draw the forces here and there. Okay, and then the other thing I want to do is I want to call this v1 and v2. Okay, so this is v1 and v2 points like this, just to kind of connect them. And then we want to know the change in v. Well, let's be clear. Delta v equals v1 minus, delta v equals v2 minus v1. So the force part didn't really help, but I like to draw it anyway. So this is going to be v2 plus negative v1. So what that means is if I have v2 going this way, excuse me, v1, negative v1, points like this. So if I were going to add it, the way adding vectors works is I take the head of one. You know what? I'm going to use a different color. So I'm going to draw, I'm going to draw v1 heading back this way. So this is negative v1 as a vector. And so I'm going to take v2, okay, and add that negative v1 to it. So I'm going to connect the tail of v2 to the head of v1, and this vector will be delta v. And so the answer that I'm actually going to get ends up being choice C. They did it a little bit differently. So that's the idea. All right. So that's question number 13.